Greetings, STEM 2 students. Welcome to section 8.2. And what we're going to look at today is relationships among angles inside polygons, and particularly regular polygons. So I want to kind of start your lesson today thinking about what you learned yesterday. And yesterday with your work through Mr. Cross and Mr. Long, you discovered that exterior angle polygons always add up to um, 360. And so I think your copy should say the exterior angle sum. If it doesn't, go ahead and squeeze that in there. In other words, if we add up all the exterior angles, we get 360. And you'll notice it doesn't depend upon the number of sides. So even if we have 10 sides, 360. If you have 8 sides, 20 sides, 200 sides, it doesn't matter. Always going to add up to 360 as long as we have what's called a convex polygon. And we'll talk about that down here in just a minute. So basically it's 360 is kind of the magic number to remember when dealing with exterior angles. So my memory aid item for that is to remember the game console, Xbox 360, because exterior angles have a sum of 360. So maybe that's just a little way to jog your memory of Xbox 360, exterior angle sum 360. Okay, so this is going to be true for all of your convex polygons. So let's just draw an example. And I'll put convex on the left and concave on the right. And we'll draw a few of each just to kind of see the difference. Convex is going to be, your main basic images like say a rhombus is going to be considered convex, a rectangle, a triangle. Let's see what else we have here. This particular pentagon is convex. It doesn't necessarily depend upon the number of sides, but the way the sides are put together. So I'll give you some examples of what are considered concave. So concave might be something like this arrow. It might be this, well, it was supposed to look like a cross until I screwed it up. But basically like this cross here. And you'll notice concave shapes if you start at any vertex. So let's just say I pick this vertex and this vertex. Convex is always going to have it so that you can draw a line on the exterior of the shape. So I'm just going to say a little note here. Convex can use that line I just drew is called a diagonal. Can use a diagonal to connect two vertices on the exterior of the polygon. Where like the ones over here for convex, no matter where I try to draw this line, it's either going to be, the line's either going to be inside the shape to connect one vertex to another. It might be on the shape, but you'll notice it's never on the exterior. So I'm just going to note that. Never on the exterior. A lot of students just remember concave has a spot where it caves in. That's fine. I'm not going to ask for definitions on this. You just have to know how to apply it. Okay? So we're going to use those diagonals to kind of play around with some multiple-sided shapes. Notice on this page, all of these are convex. None of them cave in. And so the patterns we're looking at today are all relative to convex. And I suppose concave has some patterns, but we are not by any means in regular geometry at any point going to investigate those. Okay, so we're just going to fill out this chart together. So if you look at each shape, this particular shape has 3 sides. And if we draw lines, kind of like, I'm going to call it like a seashell effect. If you start at one vertex and try to draw a line connecting it to all the other vertices, so in a way that the triangles don't overlap, we're just going to count up how many triangles we create. So this first triangle, if I try to connect to the other vertices, it just gives me the edges of the triangle. And so there's only one triangle that exists. But you'll notice on the other one, I don't want to draw one here because now those lines overlap. So we have one triangle on the left, a second one on the right. So there's 4 sides, but only 2 triangles that don't overlap. Okay, it doesn't matter which vertex you start at, but again, I'm just going to connect it to all of the other vertices. Obviously, I'm not going to draw the one next to it because it would be the edge of the polygon. But all the other vertices I'm going to connect to. And so this time we'll see that this is a pentagon. So there are 5 sides with 3 triangles that don't overlap. So hopefully you're noticing a pattern with these numbers. This next, it's called a hexagon. So if I connect it here, we're going to get some triangles as well. So here we get 1, 2, 3, 4 triangles that don't overlap. And the original polygon had 6 sides. Well, hopefully you're noticing this pattern here. Okay, notice these are always differing by 2. So on the 7-sided polygon, we should get 5 non-overlapping triangles. 1, 2, 4 lines, but 1, 2, 3, 4, 5 triangles. And so that pattern will continue infinitely here. As we add a side, we'll always have 2 less triangles. Okay, so let's talk about the names of these shapes. At the high school level, it is pretty much expected that you have these names memorized. I'll tell you that right now. So just kind of be aware that I'll expect this to be memorized. Okay. Let's go ahead and name these here. So the 3-sided obviously is the triangle. And I'm going to work on my sizing here. Let's put that at 18. There we go. And bear with me as I make this something I can replicate easily. All right, the next one, 4 sides. A lot of people want to say square or rectangle, but it doesn't always form one of those 2 patterns. So we'll say quadrilateral. Quad meaning 4. 5-sided is like the government building, and this is called the Pentagon. 6 sides is hexagon. Guys, remember hex, 6, they kind of sound alike. 7 is a little harder to remember. This is called a heptagon. 8, prefix for like octopus, octomom. You may remember that in the news years ago. Might be too young for that. Octagon. 9 is my favorite word. I don't know why. I just think it's a cool shape name. It's the nonagon. And then the 10 is the decagon. And once we get past 10, you don't have to memorize. Mathematicians get really lazy. So they call them n-gons. So like if there's 35 sides, they call it a 35-gon. So we'll just say n-gon, and n gets replaced with the number of sides. Okay, so going back to our chart. On the 3-sided triangle, we had 1 non-overlapping triangle inside of it. The 4-sided quadrilateral, we had 2 triangles, and you're going to see a pattern here. 5-sided, we had 3. 6-sided, we had 4. And so again, just kind of filling this pattern in, you'll notice they just go right in order. Okay. Oops. Oh, shoot, I deleted that. Okay. Let me just do this. Now, the last one is where we're going to start to develop the pattern. Okay. I'm going to wait to answer that one until we get the rest of the row filled out. But what I want you to look at is back up at the top here. This triangle on the interior has 180 degrees. And so we've been working with that one all year. We know triangles have an interior sum of 180. But once we get to a 4-sided shape, now you have 2 triangles. So we're going to have 2 groups of 180 for a total of 360. Okay, and so again, I'm going to kind of take one of these words here and we'll start to make a pattern here. All right, on this one we have 3 groups of 180. So I'll scroll back to the top in just a minute. That's 540 degrees. So check this out. Right here, 1, to 3 triangles. 3 times 180 is 540. So if we start to use this pattern, you know, the rest of the chart's pretty easy. It's to be 4 groups of 180, making it 720. 5 groups of 180, making it 900. 6 groups of 180, which is 1080. You'll start to kind of notice, again, lots of patterns, both vertically and horizontally in the chart here. 7 of these would be 1, 2, 6, 0, doing my mental math. 8 of these would be 1440. So I guess the point being, we don't want to make a chart going all the way to like 24 sides, but what I do want you to notice is if I start with this number, I'm going to call this column N, N representing the number of sides. To go to the next column, every single time I'm subtracting 2. So I'm going to say if this column is N, this column is going to be N take away 2. And if you notice, whatever we see here always matches this part of the formula. So basically, instead of writing 8, 7, 6, 5, 4, 3, 2, 1, I'm just going to write N minus 2. N minus 2 times 180 will always tell us the interior angle sum. And I would star that formula. We're going to use that baby a ton, both today and the rest of this chapter. So circle that. That's a big one. You want to kind of, I don't want to say memorize, because really, as long as you understand the triangle concept, there's always going to be 2 less triangles, because you're never drawing the triangle to the neighboring sides. You're drawing it to everything but the neighboring side. So that removes 2 of the sides. Okay. Okay, now let's apply this stuff. So if you'll notice on this polygon, I want you to go ahead and create congruency marks on the sides and also on all of the angles. So go ahead and just draw in those arcs. All right. Now, we're not going to mark this like this every time, but we're going to be using polygons that look similar to this. So what's the easier way if we don't want to mark this all? We just use the vocabulary of the word regular. And so by using the word regular, we are saying that all sides are congruent and all angles are congruent. All right, and again, of course, mathematicians have to make fancy words for things. And so all sides congruent, we've seen this word before. That's equilateral. And all angles congruent, again, we've seen that. That's called equiangular. So just once you see those 2 properties true, you can just say the shape is regular. It's literally the same meaning. Okay. So here's what I want you to look at. On this particular polygon, we're going to be focusing on the number of sides. But the first question is not related to the number of sides at all. The exterior sum is always going to be 360. Okay? But if you notice, we have 1, 2, 3, 4, 5, 6 exterior angles. And we have to divide that 360 into equal parts. Since it's a regular polygon, all those angles are the same. So it says, how could you find the measure of each, let's say that should be exterior angle. So just make sure we're referring to exterior. All right, well, the way we could do that is we could just take that 360, divide 360 by the number of sides. Divide 360 by the number of sides. So in this case, we're looking at 360 divided by 6. So I'm just going to mark my picture. 360 divided by 6, which in this case would be 60 degrees. So this little exterior angle right here is going to be 60 degrees. Okay. Now label each exterior angle. Okay, well, I'm going to do that. You don't have to, but just since it's the first time we've done it, I want you to see the pattern. So those are all going to be 60. Okay. All right, now what's the sum of the adjacent interior and exterior angles? In other words, if we focus on this, this linear pair, those two angles, since they're a linear pair, are always going to have a sum of 180 degrees. So if we know the interior is 60, the exterior angle, if the exterior is 60, the interior would be 120. All right, and so if these are each 120, oh gosh, I'm glad we don't have to do this every time, just when we are looking for patterns. Okay, those are each 120, so if we want the sum of those, we're just going to add those all up, or for simplicity's sake, we have 1, 2, 3, we have 6 of those. The interior angle sum is just going to be 120 times 6, which is what, 720? Okay. Now, this is kind of cool. If we flip back to the other page, 6-sided polygon, right? Look at our chart. 6-sided polygon, 4 triangles on the inside. Boom, 720 right there. Please don't try to memorize these numbers. Just understand the formula. It's way easier than memorizing all of it. Okay, so in summary, the exterior sum is 360. Each exterior angle is 60. And we got this by doing 360 divided by the number of sides. I'll just put n. Each interior angle was 120 because it was supplementary to these two are always supplementary. I'm just going to put that here. Sup. All right. And then the exterior, what is this? This should say interior, not exterior. That's why I was confused. The interior sum was 720. All right, your job at this point is to go ahead and pause the video, give this one a try. I would always start with these problems by extending this and just starting right off the bat with 360 divided by number of sides. Once you get this little angle, all the rest of them will follow very easily. So pause it, unpause it when you're done, and then I'll put the solutions up right now. All right, now you've had a chance to check your answers. We got one last topic, and that is it for the lesson today. Okay. Non-regular polygons. You can kind of see in this picture right off the bat, we have different angle measures. I did forget to print all my degree symbols, so if you want to go through and add those degrees, that'd be awesome. So you don't think they're a length. Okay, we're focusing on angles today. Non-regular polygons, really, two things are going to happen. We're going to have the sides. Let me just use the writing tool. The sides aren't congruent. That's one option. And sometimes, you know, they don't label the sides. The other option would be if the sides aren't congruent, and you can't have one without the other. But sometimes they don't label everything. But either the sides aren't the same length or the angles are different. you know that those are not regular polygons, okay? But the sum, this interior sum, is still going to be based upon the number of sides. So here, let's just put a few things to notice. What we want to do is solve for x and y. So I want you to pause the video right now, and I want you to give this a try on your own, okay? Now that you've had a chance to think through that process, let me just kind of walk through a couple ways to think about this. Really, there's two different focuses to solving this problem. If we start with the interior focus, which some of you may have, if you do an interior focus, we're using the fact that the number of sides take away 2 times 180 degrees gives us the interior sum. Okay, well, in this case, there are 5 sides to our polygon. So if we take 5 minus 2, which is 3, times 180 degrees, we know that inside this polygon, all of these 5 angles have to add up to 540. So that means that the 100 degrees plus the 110 plus the 70 plus the 130 plus this last one that we don't know has to add up to 540. Well, let's just do the math on that. These 4, I'm just going to add these 4 together to see how much we've used. Think of it like a bank account, like how much you spent. You used this much money. You know, this is how much money you had to start with. If you spent all of your other money, your X is just what's left in your bank account. So I'm going to add those up. We got 100 and 110 and 70 and 130. So far I've used 410 degrees. And then X, this interior angle, whatever that is, has to make it add up to 540. Well, that's a pretty easy algebra problem. We can just subtract out how much we've used, see what's left over. Okay, there's that. So that's what, 130? And then once we know this one, we know that X and Y are supplementary. So then this one has to be 50. So X is 130 and Y is 50. All right, now the other way, if you did this focusing on the exterior angles, I'll do that pattern in red. Some students prefer to work with exteriors because they know that sum is always 360. So I've seen a lot of students do this where they take and they kind of work with each supplemental pair and they go, okay, well that's going to be 80. Let's see, these 2 right here have to add up to 180, so that's got to be 70. These ones have to add up to 180, so that's got to be 110. These add up to 180, so that's got to be 50. Well, these red ones, along with the Y, those have to add up to 360 always. And so if you kind of do the math on that, what happens is it turns out that the 80, the 70, the 50, and the 110 add up to 310. And so basically if you say, okay, well, we got 360 total. We've used 310. That leaves 50 for Y. Once you figure out 50, see the supplement here works the same way. 50 and the 130 are still supplementary. So then you've got them both figured out. All right, hope that helps. The assignment is worksheet 8.2. That will be due Wednesday. Stop in with any questions that you have outside of class. Thanks.